Vertical circles, we're going to look at the tension in the rope now. So we got our favorite chemistry teacher, he's tied to this rope. We figured out how to determine what the minimum velocity would be to get around here. So you're gonna get your minimum velocity, you're gonna be speeding up to get to the bottom here, and then you're gonna count on that momentum to carry you around just at your minimum velocity. That we don't care about anymore. Now you're just being told, okay, look, we got this vertical circle. The top's not that great, but that's gonna be okay. The circle itself has got a radius of 20, so that's how long the rope is, 20 meters. 85 kilograms is the mass. And the velocity at the bottom, so I just called it v-bot, is 8 meters per second. That has nothing to do with at the top here. So you can't find your v minimum and then figure out that this is 8. I just made the question up, so. Okay, here we go. What we want to do is just do a little bit of vector analysis here. You're going to have a force due to gravity pulling you down, and you'd have a tension holding you up. So they're in opposite directions. So you would end up doing your sum of forces. You would end up saying tension. Well, here, let's just do it. Sum of forces. You're going to go tension plus force of gravity in the opposite direction is going to be equal to, in this case though, it's going to be equal to our Fc. So tension minus force of gravity is equal to Fc. I guess we should actually, oh, I already said that here. We're going to find tension. Tensions are unknown. So tension would equal Fc plus Fg. So let's figure it out. Simple equation. That's going to be mv squared over r plus mg. There's going to be no canceling this time. There's no subtracting. You're just saying whatever your centripetal force is plus that extra little bit of gravity pulling down is going to be what your tension in that rope is going to be. So that's going to be 85, 8 squared over 20 meter rope plus 85 times gravity, which I've gotten lazy again, I'll call it 10. Plug all that into your calculator, you will come out with 1122 newtons. That is the tension in the rope. There you go. That is vertical circles with tensions. I think you can see that if you were going to do the tension at the top at a certain velocity, you would just end up subtracting off your force due to gravity. So you'd find your centripetal force, subtract off the gravity, and your tension would be less. And that makes sense, right? Bottom of a circle, your tension should be more than at the top.